Good morning, trigonometry class. Today we are going to be doing a lesson on 12.2, which is entitled Arithmetic Sequences. In your notes, please go ahead and copy down the definition box, which is on page 528. I've written it here for your convenience. If you have to pause the video if I go too fast, please do so you can copy this down. In an arithmetic sequence, the difference of any two consecutive terms, so consecutive as in back-to-back, so the first term and the second term, or the second and the third term, or the seventh and the eighth term. So the difference between any two consecutive terms is a constant called the common difference, which is denoted by a D, which makes sense because difference, D, I like it. All right, symbolically, A sub n minus A sub n minus 1 equals D. So in other words, if I'm at any term, if I'm at any term and I subtract the term before it, I will get that common difference D. All right, let's advance. All right, so let's try a couple. What is the common difference in each arithmetic sequence below? All right, so in the first one, I have 2, then I go to 5, then 8, then 11, then 14. Let me make sure there is a clear pattern by adding. So it looks like I'm adding 3, adding 3, adding 3, adding 3. Definitely the common difference. If you thought it was 3, you're correct. All right, let's look at the next one. To go from 1 to 1 to 1 to 1, all right. I'm going to say plus 0. Plus 0, plus 0, plus 0. The common difference is always 0. Correct again. All right, in the next one, I know it might look like you're subtracting, but I still want to think of it as adding. So I'm going to think of it as plus negative 2, plus negative 2, plus negative 2, because I am, in essence, subtracting 2 or adding negative 2 each time. All right, you're doing great so far. Let's go ahead and go through example 1 together. All right, before we do example 1, you may be thinking, wait a second, Mrs. Travers has a whiteboard and the marker that we always use in class. Is this one of our whiteboards? Oh, this is definitely one of our whiteboards. Yes, I went through a GCCS drive-thru to pick up the 2nd grade packet, and I picked up our whiteboards too. All right, so example 1. Determine whether or not each sequence is arithmetic. If it is, state the common difference. All right, so let's make sure there's a clear pattern that we can get by adding or subtracting, which is the same thing as adding a negative. So let's look at the first one, A. How do I get from negative 5 to negative 2 to 1 to 4? Looks like I add 3, add 3, add 3, okay? This is definite yes, arithmetic sequence, common difference, 3. All right, letter B. If I want to go from 3 to negative 3 to 3 to negative 3. Okay, so it looks like first I add 6. Subtract 6, excuse me. First I subtract 6, then I add 6, then I subtract 6. Okay, this is not the same pattern every time, so this is not an arithmetic sequence. All right, next one, 5 to 5 to 5 to 5. Looks like plus 0, plus 0, plus 0. Definite yes. Common difference, 0. Oof. This one is a little harder to see. I could use the formula and I could take a given term and subtract the previous term and see what that is. But then I'm going to have to do it every time. Take this given term, subtract that. Take this given term, subtract that. That kind of seems like a lot of work. I think I'm going to go common denominator here. So why don't I change everything and write it in terms of 6? So if I want to write 1/3 in terms of 6, I could make it 2 6 if I multiply the top and the bottom by 2. So let's change it to 2 6. If I want to change 1/2, let me multiply top and bottom by 3. Let's make that 3 6. If I want to change this to 6, multiply top and bottom by 2. That'd be 4 6 and 5. All right, and 5 6. It looks to me like I added 1 6, added 1 6, added 1 6. This is an arithmetic sequence, and the common difference is 1 6. All right, awesome. Let's keep going with our notes here. All right, in your notes, I'd like you to write down your formulas that are on pages 528 and 529. The first form, and I have them written here again for your convenience. Your first one, your recursive formula for arithmetic sequences. A sub n equals A sub n minus 1 plus D, the common difference, where A sub 1, or the first term, is given. Now, I added this little note that you might find helpful to put in your notes as well. In this situation, you just need to plug in D. It is important to note that all you need to do is plug in D with this formula, and then you have a formula. So you might want to jot that down for future reference. All right, let's move on to the pink one, the explicit formula for arithmetic sequences. This time we have a sub n equals a sub 1 plus the quantity of n minus 1 times d. So we have a given term equals the first term plus the quantity of n minus 1 times the common difference. In this case, we just need to plug in a sub 1 and d, and we'll have a formula. Nice, because in my formula, I'm going to want to have an a sub n, and I'm going to want to have an n. So if I could just fill in that first term and the common difference, I'd be good to go. All right, one more formula before we do our next example, and that is the Generalized Explicit Formula for Arithmetic Sequences. All right, that sounded really similar to what we had before, so let me peek back up. In pink, this is the Explicit Formula for Arithmetic Sequences. Notice I know the first term. Now when I want to use this Generalized Explicit Formula for Arithmetic Sequences, this is for when I don't know the first term. You might want to note that in your notes. So when you're going to use the generalized when you don't know the first term, you're going to use the explicit formula when you know the first term. All right, so let's read this generalized explicit formula. A sub n equals a sub k plus the quantity of n minus k all times d. These might look a tiny bit confusing now, but I think you're really going to enjoy having formulas to just plug in and work with as we move on with this lesson. Again, note the formula written in purple, I use that when I do not know the first term. The formula in pink, I use when I do know the first term. All right, we're going to take a look at example 2 together. And I already kind of put here so we know what formula to use, but we'll see in a second. Since we know the first term and we know d, we're going to be able to use our explicit formula, not that generalized explicit. So let's go ahead and take a look at example 2 together. For example 2, it wants me to write both a recursive formula and a simplified explicit formula for the arithmetic sequence 2, 7, 12, 17, da, 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 da. All right, now I already extracted my formulas from our notes. So I have my formula for recursive sequence, which remember is this, and I even noted where a sub 1 equals, who knows, and my formula for explicit. All right, so taking a look at the sequence given, I think it would be helpful if I identified what is my first term and what is my common difference. Now note that this says it's an arithmetic sequence already, so I already know that going in. But I'm just going to note my first term, which is 2, first term of the sequence. And common difference, how do I always get to the next term? What is that? Plus 5, plus 5, plus 5. All right, my common difference is 5. So we have all the important information we need. My recursive formula, remember, all I really need to plug in is d. Although I guess I should say you need to plug in d and your first term. So let's do our formula here. A sub n equals a sub n minus 1 plus 5, because d is 5, where a sub 1 equals 2. All right. Recursive formula is a piece of cake with arithmetic sequences. What about explicit? This one looks like a little more work. So a sub n equals, plug in that first term, 2 plus n minus 1. Notice I'd leave the n. It's fine to have an n in your formula. Times the common difference of 5. All right. Although this looks good so far, I really want my formula to be simplified. I don't like doing this, but I really need to distribute from the back to simplify this formula. So that will give me a sub n equals 2 plus 5n minus 5. Combine like terms here with my 2 and my negative 5. So I'm going to get a sub n equals, we'll keep the 5n, 2 minus 5, that's negative 3. And there you have your simplified explicit formula. Now, you're going to have to get used to this distributing from the back. I know that's not the way you're used to seeing it, but this does need to go into the entire parentheses, so just be ready to do this at the time. Now, let's say you're wondering if this formula is correct. Sometimes I like to check it, so I'm going to check my fourth term. My fourth term is supposed to be a 17. If I plug in a 4 here, 5 times 4 is 20 minus 3, 17. I feel really confident that this formula does work. All right, let's head back to our notes before we go into the next example. All right, the next example we are going to do is example 3, but I just wanted to make a quick note here that I'm going to have to use my generalized explicit formula, and it's going to help if I label my k, my a sub k, my n, my a sub n, and I'm also going to notice that the math typically works out nicely if I choose to make n larger than k. So we get to pick which number becomes n and which number becomes k each time. Doesn't matter, you can pick either one. but you might find that if you pick n to be the larger number, it's just a little bit easier. So that's how I'm going to work out example 3. So let's go ahead and check that out. All right, example 3 tells us to write an explicit formula for an arithmetic sequence with a sub 3 equal to 11. So the third term is 11, and a sub 7 equals 23. The seventh term is 23. Now this is an arithmetic sequence. I could kind of play with the numbers a little bit and try and find out how to do this, but let me do this the official way with the sequence. All right, so I need to decide which number I want to be my n and which number I want to be my k between 3 and 7. I'm going to make 7 my n because I like to make n bigger. So if n equals 7, that means this is an n, so a sub n would equal 23. All right, it's important to kind of define that in the beginning of my problem. So n is 7, and I'm going to make my k 3. So plug in a k here, which means a sub k equals 11. Okay, so this is our important info that we will use for our formula. All right. That being said, you could have reversed this. You could have made K7 and N3 and kind of reversed all these. That would work too, but let's go ahead and just follow it this way. All right, so let me plug in all the information I know into my formula. So A sub N is 23 equals A sub K, that's 11, plus N is 7 minus K is 3. D is the only thing I don't know. So I'm essentially doing all this to find D. So let's go ahead and finish. Order of operations says I should do my parentheses first. So that's 4. So let's fill that in. 23 equals 11 plus 4D. All right, let's go ahead and solve for D by subtracting 11. That means that 12 equals 4D divided by 4 divided by 4. 3 equals D. 3D, nice. All right, so D equals 3. All right, I would love to say we have finished the problem, but it must be a two-stepper because I don't have an explicit formula yet. All I have is D. So same formula. Here we go again. Round 2. A sub n equals A sub k plus n minus k times D. I'm still using this formula because I still don't know my first term. Now technically you could use this D, back up your terms, and just find your first term if you really want to use your other formula. But again, let's kind of follow the problem through this way. Now in my final answer, I'm totally comfortable with having an A sub n and an n in my formula. That would be great. So all I really want to fill in is my a sub k, my k, and my d that I just solved for. So let's go ahead and leave my a sub n. Let's fill in my a sub k with 11, plus let's leave my n minus, what's our k? 3, times what is our d that we solved for? 3. All right, this looks great so far, but I am going to simplify it just like before. I have to distribute from the back, so send this in. So a sub n equals 11 plus 3n minus 9. All right, I should combine like terms here to get a simplified formula. Bring down 3n. 11 minus 9 is 2. Here is my explicit formula for the sequence. Nicely done, class. All right, let's move on to the next one. All right, please add this new term into your notes, arithmetic means. What are arithmetic means? Well, the terms between two given terms of any arithmetic sequence are called arithmetic means. And we will see what this looks like as we do example 4, just to kind of get you ready for example 4 here. You're going to find in this example that we're about to do, I'm going to end up looking for the second term, third term, and the fourth term, because I'm going to be given the first and the fifth term. And as we said, the terms between two given terms of an arithmetic sequence are called arithmetic means. So if I'm given the first and the fifth term, the terms in between are the second, third, and fourth. So we're going to see that I have to find the second, third, and fourth terms. And if I can go ahead and use my explicit formula and find D, I'm going to easily be able to find the missing arithmetic mean. So let's go ahead and try that one together. Example 4, find the 3 arithmetic means between 7 and 15. I already went ahead and extracted our explicit formula because I know the first term. So I like to use this formula whenever I know the first term rather than generalized. All right, so if I need to find the 3 between 7 and 15, I'm going to go ahead and make my first term 7. I need to find 3 missing terms in between 7 and 15. So I'm missing my second term, I'm missing my third term, I'm missing my fourth term, I know my fifth term. All right, so let's see if we can use some of that information to find D. So A1 is clearly 7. The only other information I know is that A sub 5 equals 15, which indicates to me that when n is 5, A sub 5 equals 15, because that's my 5th term. So I had to have all the information I need to solve for D. So I can put in A sub n, I'm going to put in A sub 5, or 15. So let me write it that way first with the 5. So A sub 5 equals A sub 1, which is 7, plus n, which is 5, minus 1 times D. Now we said that A sub 5 was 15, so let's fill that in. 15 equals 7 plus, let me do my parentheses, 4D. Solve for D, subtract 7 on both sides. That means 8 equals 4D. Divide by 4 on both sides. D, or my common difference, is 2. Now, I am not actually going to take the time to find the explicit formula here. I'm just going to use this common difference of 2 and find the answers, because 7 plus 2, 9, plus 2, 11, plus 2, 13, plus 2, 15, which means I know it works. So the three arithmetic means between 7 and 15 are 9, 11, and 13. Problem solved. All right, before we do example 5, you can get excited because this is our 5th and final example, and then our notes will finally be done. Don't worry. I'm just going to make a couple notes here. We can again use the explicit formula, just the regular one, not the generalized, because we're going to know the first term again. We can find D just like we did before, and then we can find the missing arithmetic mean. So I'm going to take you through another example like that. But you should know there is a cool shortcut that works when you are only looking for one arithmetic mean. So it's basically in an arithmetic sequence, the number in between two other numbers. You might be able to figure out what that shortcut is. Think about it for a little bit. See if you can come up with it on your own. But if you are really curious, it is on page 530 between example 5 and example 6. I'm not revealing it in this video. You're going to have to look it up if you want to know. All right, let's do our 5th and final example, and then your notes can be done. All right, for our final example, 5. Find the arithmetic mean between 9 and 20. Oh, so just 1 this time. All right, so my first term is 9. Then I am missing my second term, but my third term is 20. All right, this seems very manageable because my first term is given as 9. My third term is given as 20, which means that when n is 3, A sub n is 20. Just going to point that out so we can use that in our formula over here to find D. All right, let's go for it. We're going to find D just like before. So I'm going to use n as 3 here because I know that third term. So A sub 3 equals A sub 1, 9, plus n, 3, minus 1. Common difference is what I'm looking for. Better keep that. All right, what was A sub 3? 20. All right, so 20 equals 9 plus 3 minus 1 is 2D. All right, I'm solving for D. Let me subtract 9 on both sides. That would mean, ooh, this is going to be ugly. 11 equals 2D. Divide both sides by 2. D equals, I guess I'll change it to a 5.5 in this case. 5.5 or 11 over 2. Either one is fine. Now that we have D, let's just go ahead and apply it rather than come up with the formula. So it is 9 plus 5.5, 14.5. Add 5.5 to that, and I do get 20. So this works. That means the arithmetic mean between 9 and 20 is 14.5. And I hope that there are some curious people, first of all, that might be able to see a good shortcut for this anyway. If I'm looking for the number directly in between 9 and 20, how do I find it? I know you know how to do that. But if you can't think of it, go ahead and peek in the book to see what that shortcut is, because it is a more fun way to do it than this. All right, I hope this made sense. If you have any questions, please do not hesitate to contact me. We can do a one-on-one like meet video. I can respond via Google Classroom or email comments, but I want to make sure that you feel like I can help you if you need it. I look forward to you watching this video. I know it was kind of long. I'm sorry, but I did try and condense it as much as possible. Have a wonderful rest of your day. Bye.